Okay, we're moving toward adding rational expressions. Oh. And of course, the reason we started the class off with adding fractions and multiplying fractions is because we were going to get to this point, and here we are. Okay, so here's our point. Now, we started with the problem 5/8 plus 4/3. We want to add these. We can only add fractions if they have the same denominator, and these have different denominators. Okay, they have very different denominators. Now, in this case, what we can do is we can give both the same denominator. Take 5/8 and multiply that by 3/3. The denominator is going to become 8 times 3. It's 24. Just think 8 times 3 for the moment. And then we have 4/3, and we multiply that by 8/8. Again, the reason that works, we're not going to belabor the point, we made it much earlier, but 3/3 is just like it's 1. So if we multiply 5/8 by 1, we don't change its value, we just change the way it's expressed. And similarly, we multiply 4/3 by 8/8. We're not changing the value of this fraction, we're just expressing it with slightly different numbers, well, significantly different numbers, I guess. And that equals then 5 times 3 is 15, 8 times 3 is 24. And over here we have 32/24. Now that we have the same denominator, we can write this as 15 plus 32/24, which equals 47/24. Now we normally attempt to reduce this, but 47 is a prime number. We can verify that. And it's not going to be divided by anything else, so we can't reduce this fraction. Okay. So let's just see if we can do this with numbers. Let's give you another example. Let's say we have 5/7 plus 9/4. What can we do with this? Okay, so with 5/7 plus 9/4, we were able to do 5/7 times 4/4 plus 9/4 times 7/7, which equals 20/28 plus 63/28, which ends up being 83/28. Okay, so that's pretty good. Okay, now applying the same thing, we made some good progress on the next question, which was if we got x/4 plus x/7, what you can do is, again, multiply numerator denominator here by 4, multiply numerator denominator by 7. Now, you get a denominator of 28 in each case. Of course, you got to remember to multiply x by 7 up here, which is going to give you 7x. And multiply this x by 4, I give you 4x. That's 7x plus 4x all over 28. Which is 11x over 28. Okay, so a couple of people kind of forgot to multiply by the 7 or the 4, but everybody did the right operations here, and then did the right thing from here to here. Just between here and here, maybe we forgot to multiply the x by the appropriate numbers. Okay, that's pretty good. Well, let's try this. I'll give you just a minute and see if you can think what to do for your first step. Okay, now if we follow the pattern that we used up here and here, what did we do here? We multiplied this fraction by this denominator. We multiplied the numerator denominator by this denominator. We multiplied the numerator denominator this fraction by this denominator. We're going to do the same thing here. We're going to take 4 over x plus 1 and multiply that by x plus 2 over x plus 2. Then what do you think we're going to do with 7 over x plus 2? Try that before I tell you. Okay, yeah. What everybody did. We have 7 over x plus 2. We want to multiply it by x plus 1 over x plus 1. Same pattern we used over here and up here. So we have okay. Now let's think about what happens if you multiply these numerators and multiply these denominators. Okay. So see if you can multiply those numerators and those denominators. Okay. Now, this means 4 has to multiply the x plus 2. We actually want to write this out. Rather than just writing out the answer, let's write it out. So it looks like something we can understand, because if you don't write it out like this, then you have to remember the 4 has to multiply the x and it has to multiply the 2. If you write it like this, it shows you're going to have to use a distributive law. Similarly, you're going to have to use a distributive law down here, which I know we know how to do. And here we have 7 times the quantity x plus 1 divided by x plus 2 times x plus 1. Well, 4 times quantity x plus 2 is 4x plus 8. X plus 1 times x plus 2, you know how to work this out. It's x squared plus 3x plus 2. Now, normally I wouldn't even expand this. I'd leave it like it is, because if the denominator stays factored, then you can check and make sure that the numerator you end up with doesn't have any common factors. Okay, I don't think that's going to happen in this case. Okay, so anyhow, we go ahead and multiply the 7 times the x plus 1. We get 7x plus 7. And that came out way too small. Okay. And the denominator is again x squared plus 3x plus 2. Well, what's that equal? Now that equals 4x plus 8 plus 7x plus 7, all divided by x squared plus 3x plus 2. Okay? That makes sense? Just add the numerators. There you have it. Now, can we simplify the numerator? Okay. Go ahead and see if you can write out what the numerator would be after you simplify it. Okay, good. We're well with this. So I have to put the final answer up here. But 4x and 7x adds up to 11x. 8 and 7 adds up to 15. X n over x squared plus 3x plus 2. There's your simplified final answer. Okay. So pretty good. You did well on that. Okay. Let's try we've done these three. Try that one. Same ideas all the way through. But it's going to look a little different. Just keep your head about you and see what you can do. Okay. So had a good start on this one. Okay. So we have x plus 3 over x plus 5 added to x minus 6 over x minus 4. Okay, now wrote that out nicely. We got x plus 3 over x plus 5 multiplied by x minus 4 over x minus 4. And then it's plus x minus 6 over x minus 4 multiplied by x plus 5 over x plus 5. Okay, and everybody got that. Now, in the next step, here's where I want to emphasize, and I did over here. Okay, remember what I said over here? I didn't go directly from this to this. Even I could have, and you probably could have too, but I don't go directly from this to this. I write out this and this in parentheses, okay? Just to make sure I understand, I'm going to have to use a distributive law on that, so I'm going to multiply these things. And the same thing here. I use parentheses to express this times this. Now, I don't need a parenthesis around the, or I don't need parentheses around the 7 or the 4, but I definitely need them around the two expressions, x plus 2 and x plus 1. Okay? Two binomials. I don't know why that word escaped me, but look at my age. Okay. So what we have is, I kept coming up with binary, and I knew that wasn't right. Okay. Anyhow, we have x plus 3 times x minus 4 in the numerator here. And we're going to write that as x plus 3 times x minus 4. I'm writing it big, partly so everybody can see it, and partly just to emphasize it. And then we're going to have in the denominator x plus 5 times x minus 4. Okay? Now, everybody doing real well with multiplying these things. But if you try to multiply these two things and don't write them like this, I don't think you're going to do well with them. Okay? I think you're going to do something, you're going to be more likely to do something that isn't appropriate. It doesn't multiply the two. Okay? So we want to make sure we include this step. X minus 6 times x plus 5 over x minus 4 times x plus 5. Okay, now you can proceed because I think everybody, unless they make a little slip up, is going to get these. So let's see what we can do with that. Okay, now I don't want to wait for everybody to multiply all these out, but everybody's doing all right in the first couple. So let's just do this. Remember, two binomials, you got to multiply these using the distributive law. Be like x times x minus 4 plus 3 times x minus 4. And that's going to give you x squared minus 4x plus 3x minus 12. The denominator is going to be x squared plus, let's do that order, minus 4x plus 5x minus 20. Over here, we're going to get x squared minus, I'm going to do them all in the same order, the order I see most people do them, which is not the order I usually use, but the order in which we do these operations, as long as they're valid. Perfectly all right either way. Okay, so we have x squared plus 5x minus 6x minus 30. Down here, we're going to get x squared minus 4x plus 5x minus 20. Okay, now that's just straightforward. Everybody knows how to multiply binomials, but I did have to jog a couple of memories to make sure, but as soon as I did that, I was thinking, oh yeah, this is what you do. Okay, then, of course, we combine our like terms. And I believe we get this. Not going to read it to you, it's right there. And then we add the two numerators. Well, then we got x squared plus x squared, which is 2x squared. We got minus x and minus x, which is minus 2x. We have minus 12 minus 30, which is minus 42. All that divided by x squared plus x minus 20. The next thing we want to do is factor the numerator and see if it has any factors in common with the denominator, because if it does, we can divide them out. In this case, it doesn't, because we're getting like 2 times the quantity x. Wait a minute. Yeah, well, it doesn't factor. Okay. Numerator here doesn't factor in the integers. So nothing's going to help here, except that we probably factor out that 2. I'll this is 2 times the quantity x squared minus 2x minus 21 over x squared plus x minus 20. And this doesn't factor. Okay. 21 can factor into 7 and 3 or 21 and 1. In either case, the bigger number is too big. You're never going to get a -2 out of it. So that's really the process. And if you master that process, you do pretty well in this assignment. And I think everybody has the tools to do that, at least everybody in class. And I think looking at the scores on the homework, pretty much everybody throughout the course has those skills. Although I can't tell for sure about people that are doing their homework all online, and I don't see it. Okay. Okay, and we have one more example. It would be this one. Now, what we need to do is we first need to factor everything. We're going to factor the denominators. Okay, so we're going to get 2 over x plus 3 times x plus 2 minus 4x over x minus 3 times x plus 2. And I wrote that out kind of badly. So let me just write it down. 2 over x plus 3 times x plus 2 minus 4x over x minus 3 times x plus 2. Now we identify the common denominator. I could multiply the numerator and denominator of this by the denominator of this one, and multiply the numerator and denominator of this one by the denominator of this one. That would be extra work. All the common denominator needs, it needs x plus 3, and it needs x plus 2. It needs x minus 3, but it doesn't need another x plus 2. Okay, so if we multiply both sides, numerator and denominator of this by this, numerator and denominator of this by this, we'd have more than we need. So we want to get this common denominator, and in order to get that common denominator, all we need to make this denominator agree with the common denominator is we need x minus 3. Then it's all going to work out. So all we do is we multiply this one by x minus 3 over x minus 3. Now in this one, we've already got x minus 3 times x plus 2. And we multiply that by what? It's going to be, what don't we have? We've got x minus 3, we got that. Sorry, we got x minus 3. We got x plus 2, we need an x plus 3. So we multiply by x plus 3 over x plus 3. And then we simply continue. And we're not going to take the time to work this out. We'll talk more about this next time because I don't think you need it until after next time. But that kind of wraps up the basics of what we have to do to add and subtract rational expressions.